Welcome to our video on binary subtraction. Today, we're going to tackle one of the most interesting and complex topics in binary arithmetic, subtracting 23 from 50 using borrowing of ones and ones complement. This topic might seem daunting at first, but trust me, by the end of this video, you'll have a solid grasp on how it works. Binary subtraction is an essential skill for anyone working with computer programming or digital electronics. It's used extensively in various applications, from simple calculators to complex algorithms. Understanding binary subtraction can help you appreciate the intricacies of computer architecture and programming. In this video, we'll break down the process of subtracting 23 from 50 in binary using borrowing of ones and ones complement. We'll cover the key concepts, steps involved, and provide examples to illustrate each point. By the end of this video, you'll be able to tackle similar problems with confidence. Let's start by understanding the concept of borrowing in binary subtraction. In decimal subtraction, when we subtract a larger number from a smaller one, we borrow 10 from the next digit. Similarly, in binary subtraction, we borrow 2, which is equivalent to 1 in binary, from the next digit. Now, let's move on to our problem, subtracting 23 from 50 in binary. First, we need to represent these numbers in binary form. The binary representation of 50 is 100 and 10,010, and that of 23 is 10,111. Next, we align the two numbers vertically, with the most significant bit, MSB, on top. We then start subtracting from the rightmost digit, just like we do in decimal subtraction. When we subtract 1 from 0 in binary, we need to borrow 1 from the next digit. This is where things get interesting. And in our case, when we try to subtract 10,111 from 110,010, we encounter a situation where we need to borrow ones multiple times. To make this process easier, we use the concept of ones complement. The ones complement of a binary number is obtained by flipping all its bits. That is, changing all zeros to ones and vice versa. By taking the ones complement of the subtrahend, the number being subtracted, we can simplify the borrowing process. This allows us to perform the subtraction without having to worry about multiple borrow. Let's walk through an example to illustrate this concept. Suppose we want to subtract 11 from 101 in binary using ones complement. We first take the ones complement of 11, which is 100. Then we add 100 to 101. And finally, we add 1, since we took the ones complement. Using this approach, we can simplify the process of subtracting 23 from 50 in binary by taking the ones complement of 23 and adding it to 50. We can obtain the correct result. To summarize, when subtracting one binary number from another using borrowing of ones and ones complement, we need to borrow 2, which is equivalent to 1 in binary, from the next digit when subtracting a larger number from a smaller one. We use the concept of ones complement to simplify the borrowing process. By taking the ones complement of the subtrahend, we can perform the subtraction without having to worry about multiple borrows. And that's it. I hope this video has helped you understand how to subtract one binary number from another using borrowing of ones and ones complement. Remember, practice makes perfect. Try solving a few examples on your own to reinforce your understanding. If you have any questions or need further clarification, please ask in the comments below. Don't forget to like this video and subscribe for more content related to computer science and programming. Thanks for watching, and we'll see you in the next video.